My guest today is Professor Gualtiero Piccinini, who is Professor of Philosophy at the University of Missouri in Columbia. University of Missouri, Columbia, I should say. Um, his main interests include computational theories of mind and the relation between psychology and neuroscience, consciousness, and intentionality. Welcome, Gualtiero.
Thank you. Thanks for having me, Gil.
Yeah, thanks for doing this. So, as I mentioned, I have no background in philosophy, neuroscience, or cognitive science. So, this will be quite interesting conversation for me, if not for you. um, and so you sent me some book chapters and papers, and I want to start with new foundations for the philosophy of mind and the mind sciences. So you say here, perhaps there was a time when psychologists and philosophers of mind could theorize about the mind fruitfully while largely ignoring neuroscience. That time has long passed. The essays in this volume make a powerful case that deepening our understanding of the mind requires integrating psychology and neuroscience. Yeah, so this sounds very interesting, Gultira. So, um, from my naive perspective, um, psychology is like software, neuroscience is like hardware. So if I buy an IBM computer, uh, that's neuroscience. But then I have to put Windows 11 or whatever number they have come up with, and the psychology. That's how make the machine useful for people. So integration of psychology and neuroscience is quite an important concept, isn't it?
Yes, and your analogy is precisely the driving analogy between the idea that psychology is autonomous from neuroscience. So, a lot of people for a long time, they've used exactly that analogy. Well, we're psychologists, we're just going to worry about the software. It doesn't matter too much how the hardware works as long as it can run the software.
Hmm.
But it turns out there is now very solid evidence that that analogy does not, in fact, apply to the brain in the way that, these people traditionally thought. And
Hmm.
insofar as there is software in the brain, it's so intertwined with the hardware that you really need to understand the hardware to also understand the software. You can't
It's
just
almost like
study.
firmware, not necessarily software. I mean, it's like without the
Yes.
firmware, you can't really operate anything.
Yes,
Yeah.
yes. And so this, what you refer to is the introduction to an edited volume entitled Neurocognitive Foundations of Mind that I put together, and it's coming out hopefully in September from Routledge. And each chapter covers different topics on
Hmm.
about the mind and argues that what we have learned from neuroscience makes a difference to the way we should understand that topic. And the topics
Hmm.
include things like computation, the computations that the mind carries out, the kinds of representations that it uses, the kinds of inferences that it performs, the kind of explanation that we should give when we explain mental phenomena,
Hmm.
emotions, language, thought. There's lots of different things, and there could be more, but in this volume we have a representative sample.
Yeah, it's really interesting. So, um, I think you mentioned this in the paper or elsewhere that just like Democrats and Republicans, we have people moving to one corner of the room and the other in some ways. Some argue that there's nothing in hardware. You can use the right terms. I don't know the right terms. And some argue it's all software. I mean, who cares about the hardware?
Mhm.
Is that a picture that's emerging?
Well, I would say that historically, the idea that you could study just the software, or at any rate, that you could study the mind without knowing much or worrying about much about how the brain works, that was very dominant, not only in the kind of mainstream computational theories of mind, but also in many opposite views. So there were like many connectionists who also operated in the same way. There were people into the situationist approaches like embedded inactive, embodied approaches. They also thought the same way. And there were even people who thought that philosophy of mind proper doesn't need to worry about science at all. And
Yeah.
all of them, though, they basically thought we could just ignore neuroscience. It doesn't make a difference.
Mhm.
And you know, several people, including myself, have been trying to make a case that that's myopic and it's not going to work in the long run because what we've already learned about the brain makes a difference to our understanding of how the brain, how the mind works. So we really need to study both. We need, meaning both the quote unquote software and the hardware, because they're intertwined. The functions and the structures mutually constrain each other or depend on each other in subtle ways that we need to understand.
So why do scientists sort of disaggregate this problem? Is it easier to study in a disaggregated way, or is it something else?
Okay, so first of all, I think if you look in neuroscience departments, you don't find people who believe this. If you look in psychology departments, most people don't believe this anymore, that you could just study quote unquote the software on its own without the hardware. But there are still some people in philosophy, very influential people in influential places who still operate this way. And there are some corners of psychology where people still think this way. And my best guess is that the reason why there are still people thinking this way is largely historical. Because there was a time, you know, many years ago when this was a useful research strategy. But that time has passed. That's the point that, you know, of the quote that you cited.
Yeah.
Yeah.
So that time has passed. We believe, but let me jump into something that we will talk about a little later in more detail. But artificial intelligence.
Yes.
So as I mentioned, you know, I have no background in psychology, neuroscience, or cognitive science. I've done some work in AI. I don't exactly know what that means. For about 40 years, I've been so I've been in every AI quote unquote wave and the crash of it. And now we seem to be going places again. Um, and some of the companies are investing into nuclear power plants. This is not in your research, but I want to get your perspective because they don't have enough electricity to get to general artificial intelligence, as they call it. The brain uses only 20 watts, so it
Right.
doesn't need that much energy, and we have 8 billion of them, and we haven't deployed them. So is it really worth deploying money into 3 nuclear power plants to to simulate the brain? I mean, this seems sort of brain dead from my perspective.
Yeah, that's a very good observation. There are several groups and researchers who are trying to figure out how brains process information so efficiently using so little energy. So there's a whole field of neuromorphic computation
Yeah.
that is involved in this, and there's even people trying to use reversible computation, which is a separate issue,
Hmm.
to try to save power. As far as I know, there are already techniques that are known to save a huge amount of electricity, but no one has studied very well how to scale them.
Hmm.
So yeah, so there's a disconnect between the conventional computing technology and how much energy it uses, and ways that could be used to save a lot of energy. And maybe we might need them to even save ourselves, because if we keep using so much energy and generate so much carbon emissions, we might end up killing ourselves. So this is, you know, one of the challenges of our day is to
Hmm.
see if we can transition to modes of computation that are more energy efficient. Um, and
But but
some of
but
them
but where
might
you
be
sit?
inspired by the brain. Yes.
Yeah. So sorry to interrupt. So where you sit as sort of the solution space in the sense that you have to integrate these ideas in some fashion for us to get to the truth, so to speak. I don't know if you're ever going to get there. I'm a pessimist. Good to but that appears to be the space where we could potentially find a good solution. What do you think?
Yeah, yes. And there's probably a lot of other things that we could or should do about finding a good solution, not just finding more efficient ways of processing information, but also being reasonable about our expectations about what, how much of this we need. Yeah, but market forces are what they are. So they're pushing
Market
now.
forces, yeah.
Well, they're pushing people using existing
Yes,
conventional technology because this is what people know how to do and they know how to build.
yes.
So they're going to keep building this. There's a whole supply chain infrastructure for building machines like this. So they're
Yeah.
going to continue to do that, at least for a while.
Yeah, so any computer science graduate graduating now, if you don't have artificial intelligence in your pitch, you're out of luck. And if you have that, you probably get a bunch of money, even if you don't know how to spell it.
Yeah,
That's where
yeah.
we are. I
And
mean,
if I
this
can make
is,
a
yeah,
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 if I can make a related comment about the recent explosion of artificial intelligence, indirectly, it does support my point that we need to study psychology and neuroscience together
yeah.
because the current techniques that have led to the improvements in AI are to some degree inspired by what we know about the brain and to some extent similar to what we understand about how the brain does things, which goes to show that um, we need to understand how the brain does things, even
Yeah.
for us to build technology that's more useful.
Mm. So you say here in this paper, neural representation and computation rely heavily on sensory motor codes that are widely distributed and provide semantic grounding for our language and thought, which also relies on natural language as a powerful thinking tool. So I'm very conflicted about this, Gualtiero. So I want to get your perspective on this. Um, I'm not exactly sure if natural language is a thinking tool. In other words, um, language appears to be sort of sequential. So, I mean, we have ChatGPT, which I would call it a stochastic parrot. That's my bias, obviously. But thought is not serial. I would argue. I mean, I don't know anything about it. I mean, this is my intuition. Thinking is not serial like language. What do you think?
Yes, I think that's a very good question and a very good point. I think thought it has some serial aspects to it, and because even to the extent that we can think of a whole thought at once, which I think we can, one thought leads to another. So there's still sequences of thoughts,
Mm,
one thought leading to another. But sometimes it can help us focus attention in certain ways and reason if we talk to ourselves in our own mind. This is
mm,
varies from subject to subject, but many people report talking to themselves in their
mm.
own mind. So there's this thing called inner speech, if you will,
Yeah.
and there's research on this showing that it helps people do information processing or reasoning tasks in various ways. But I
Mm,
don't think that's all there is to thought.
mm.
I think there's a lot of thought that is more holistic and parallel, if you will, where
Yeah.
we can think of whole thoughts at once and then reason that way. Um, there is a psychologist by the name of Russell Hurlburt
Hmm.
who introduced the term unsymbolized thought.
Mm.
And what he means by that is that we can have thoughts that are not accompanied by any kind of linguistic vehicle or inner speech.
Mm.
They also are not accompanied by any sensory images.
Yeah.
It's literally like sort of pure thoughts, and they're complete, and we can access them and we can reason with them, but they don't have any, at least introspectively accessible symbols like language or images. And curiously, a lot of people, I mean, not many people have tried to study thought in this way or understand it or build theories of it. And so I think this would be a very fruitful area for theorists to investigate.
It's really interesting. So, do you think dreams are sequential? The reason I'm asking is Einstein has has said that he dreamt of general theory of relativity.
Yeah.
We can get into his brain, we cannot get to his thoughts. So, do you think dreams are sequential in some ways?
Yes, I love that question for many reasons. To answer it, yes, dreams are sequential. They are successions of visual images, and some parts of them might even run almost like a little movie in your head. But interestingly, and yeah, you're right that Einstein, many other people, many other like brilliant thinkers, creative thinkers have relied on what they experienced in while sleeping to solve scientific problems or other sorts of problems. Sometimes in dreams, not necessarily only in dreams. So one thing that's not very well known is that we can think while we sleep, not necessarily by dreaming, but like by having just propositional thoughts as well. Not, again, not necessarily in a linguistic format. It's not necessarily inner speech. It can just be these whole thoughts that we can have as we sleep. And there's a very good chance, in my opinion, that that has something to do with why sometimes people wake up in the morning having solved a problem that they had not
Yeah.
solved when they went to sleep.
Yeah,
Because
that
they
has
were
happened to me
reasoning.
multiple times. Yeah,
Yes,
that
me
does
too.
happen. Yeah,
It's happened to me. Yeah.
yeah.
And I
So,
can give the audience a simple method for experimenting with this for themselves and see if they can experience this. So when you go take a nap or even go to sleep at night, you can set yourself an alarm that will like maybe set it after like 30 minutes, an hour, 45 minutes, not too long. Put it right next to your ear, not too loud, so that as soon as you hear the alarm, ask yourself right before the alarm, was I thinking about something or not? Was I dreaming? Was I thinking? Or was my mind completely blank? There was nothing there. And if you try this a few times, you might realize that sometimes, maybe a lot of the times, you were thinking about something. You might not remember what it was, but you might remember that at the time that you heard the alarm, there was a thought in your mind.
so can we use, this is not in your research, I want to get your perspective. Can we use brain scans to differentiate between dreams and, let me call it, practical thinking in some ways?
Yeah, so this goes a little beyond my expertise. I would guess that the answer is yes, because dreams would be more visual, more sensory, so they would involve parts of the brain that are normally involved in sensory processing or visual processing. But I think that, yeah, somebody should really look at this more explicitly than it's been done for you before. If they wanna collaborate about this with me, I am interested in somebody who would run experiments like that, to try to figure out which areas of the brain are involved when we do unsymbolized thought, meaning non-visual, non-sensory, but also non-speech-like.
And it doesn't have to be humans, right? So we know that mice and rats sort of replay what they have been doing in the daytime
Yes.
when they're sleeping. And that's sort of a practical construct in the sense that they're sort of reinforcing how the maze is so that they can be more efficient next time. I suspect humans are doing something similar. So perhaps the system here, Gualtiero, I'm just suggesting, are not necessarily humans. You might be able to study this in a more systematic way in non-human animals, potentially.
Yes, and people do that. The challenge is that you can't ask the rats or the non-humans, well, what were they thinking at that moment. So there's that limit, but yes, people
Yeah.
do. Yeah, people can definitely study, and that's very fascinating to study what non-human brains do during sleep. They're definitely active too. They're not just like resting or unconscious and not processing anything. There's a lot of information processing during sleep.
So I won't go into the paper, but just want to conclude. So the replay that we know exists, dreams are sort of a replay in some ways. We know mice and rats do replays of the previous experiences. The replay, is it a reinforcing mechanism? What exactly are we doing by replaying our experiences when we sleep?
This also goes beyond my expertise. I know that there's been historically a big debate about the function of dreams, which is what people usually study about what happens during sleep.
Yeah.
And part of what I'm trying to say is that there's not just dreams, there's other forms of information processing during sleep.
Mm,
Um, and some people do believe that it's a way of um, transferring information from kind of medium-term memory in the hippocampus to long-term memory in the cortex. So that's
yeah.
one theory. And I think there are other theories. I really don't have enough information to choose one theory over the other, but it's
Yeah.
an active area of investigation. It's very fascinating.
But all these things sort of support your conclusion here that um, neuroscience, we have to study the brain in more detail to really understand what's going on. But it's not just the brain, it's also behavior. It's
Yes.
an integration of the two things that are going to maybe at some point help us understand what's going
Yeah,
on. Yeah.
and it's important that all of this happens with the understanding, the awareness that the brain doesn't just work on its own.
Mm,
The brain works best when it's, immersed in a body, which normal brains are, immersed in an environment, interacting with the body and the environment. So sleep here is a bit of an exception, meaning it is the one case when brains do a lot of things sort of largely on their own without interacting with the body and the environment. But when we're awake, there's constant interaction with the body and the environment in real time, and
mm,
it's a huge part of the way that the brain works, and it gets information. It checks the information that it's getting. It checks that the actions that are being done are what the brain intended to do, and so on and so forth.
mm,
So this is not just like a brain in isolation. It's a embodied, embedded, and active brain.
yeah. So let me go into another paper. We're going to get a little technical here. So an egalitarian account of composition and realization. You say here, argue that wholes are neither identical to nor completely distinct from their parts. Instead, wholes are invariants under some transformations in their parts. Similarly, higher level properties are neither identical to nor completely distinct from their lower level realizers. Instead, higher level properties are aspects of their realizers that are invariant under some transformations in the realizers. So to get this sort of accessible to a larger group. Um, so what do you mean by whole and parts?
Yeah, thank you. Yes. Yeah, we don't have to use that jargon, but the this is a very basic uh, point about the relation between an entire system or object like a human, let's say,
Yeah.
and its parts and the properties of the whole thing, the whole human, let's say, and the properties of the parts. And there are a whole bunch of ideas about this historically. And I think most of them, if not all of them, are a bit of an obstacle to a deeper understanding of the relations between things at different scales. Okay, so even, we were talking about brains and minds and so forth. That's where some of these problems come up, because, humans, their minds, their brains, they can be studied at different scales. We can study the whole thing and how it behaves, but also, well, their mind, exactly what is that? Or the whole nervous system, but the nervous system has parts, and we can look at the parts, but those parts also have parts, and those parts also have parts, and each, at each level, there's different properties that emerge, there's different behaviors that emerge. So how do they all fit together? So there's this traditional debate about, what really matters, which level really matters, where's the real mind? Is it at this level or that level? Is it the software? Is it the hardware? But which level of hardware? Is it the whole system? Is it the system with the environment? Is it just the neurons, or is it below the neurons? Is it the subatomic particles, and so on and so on? So people have argued in different directions. Some people saying, oh, really, all that matters is the microscopic level, and that's where all the action really is. But then other people say, no, there's some higher level where the action really is. So that's where I'm coming from. And what I want to say is that to a first approximation, all levels matter. It's not that just one letter is not more there's no one level that's more important, more fundamental, more where the real action is.
Yeah.
And then I offer a framework for trying to understand the relations between these different levels, about what happens at the different levels. You can even think in terms of processes at different levels and how they depend on each other. And the important thing is they all matter, they all constrain each other, they all depend on each other, and we need to study them as many as we can, as many levels as we can, and try to integrate the information to understand the system. That's at least the first approximation. I can go into more details if you want, but hopefully.
Yeah. So let me ask you, this is not new research, but would you consider a country like the US as a whole?
Sure. It's a bit of an artificial whole, but
Oh,
so far as
you're saying it's an artificial whole. Okay. All right.
well, because
so how do you define that? Yeah.
Well, because the boundaries between countries are sort of decided and determined by us humans. They're not a natural phenomenon. But since we organize ourselves in part in relation to those boundaries, then it does have real effects in real life.
I mean, you say here, I don't know anything about this culture, so I'm just making things up. You say here wholes are invariants under some transformation in their parts.
Yes.
So if a country were a whole and 330 million people are parts, will the country remain invariant to the transformation of the parts?
Yeah, it will remain invariant in a lot of ways. Exactly which ones, that can also change to a degree. But, for example, the United States has retained the same constitution for 250 years plus. And so the same system of rules, the same system of laws, in spite of the fact that no one who was alive at the time that the Constitution was approved is alive today, or even in between. There have been many, many generations.
Yeah.
That's an example of how there's an invariant or a system of invariance, with respect to the whole, even though the parts do change.
Yeah, so many Americans might think that's an optimistic view, but we don't want to get into politics here. So this is the most important part. So you say here, nowhere in this picture is there an ontological hierarchy between levels of composition or realization. So that's sort of the fundamental point here, right? So a system is defined by its parts, and we cannot oftentimes disaggregate in I don't know what if this is called reductionism in some. So
Sometimes.
say talk more about it. Yeah.
Yeah, sometimes it's called reductionism. Yeah, and I would say a complex system is in fact not always or not generally defined by its parts. It's defined by a number of properties that it has and capacities that it has, and those will tend to stay the same or very similar from time, from one time interval to the next, even if some of the parts change. So the parts can change, but the system retains a lot of its properties. So those are the invariant properties.
It has a lot of social and policy implications too. So if your argument is right, the system remains stable and the parts change. It has a lot of social and political implications too, right? So I'm going back to sort of the countries and cultures and those types of things. So if your argument is true, countries and cultures will be invariant regardless of its composition.
To a degree.
To a degree, okay. Well, what do you mean by to a degree? I mean,
Well,
is
because
it
they also evolve, societies, countries evolve as well. They're not like going to stay exactly the same forever. But
okay?
They are certainly largely stable through changes in composition. The
Yeah.
people are born, grow up, get old, die all
Yeah.
the time, and much faster than the society changes, in some respects, at least. Yeah.
So if I understand this correctly, Gualtiero, you're saying that the characteristics of the system is stable, regardless of its components, and components could be swapped out, swapped in, change, but the system itself retains certain characteristics that are reasonably stable.
Yes.
That's a conclusion, right?
Yeah, and this is not meant to be like a novel discovery. It's just an observation that I think helps us understand the relation between parts and wholes and the properties of the parts and the properties of the whole system.
So I want to go to another one, which is a different direction. So natural hardware for the language of thought, new rules for an old game. So you say here the language of thought, lot, hypothesis posits that at least some important cognitive processes involve language-like representations. These representations must be processed by appropriate hardware. So I'll let you explain this. So I'll give you my bias so that you know where I'm coming from. Like I mentioned before, I've been in every AI wave thing. And I'm of the belief that there is no language of thought. So you have multiple gradations of lot, So the least one that you have is weak lot. I'm beyond that, Gualtiero. I'm saying no lot. There is no language of thought because we haven't quite understood thought. Yeah, so respond to that.
Yeah, so I don't think we're very far from each other. What I end up defending is the idea that, at least in some cases, natural language that we learn, in this case, we're speaking English, so we're using the natural language English, but you probably have at least one other language that you can speak, and so do I. I can speak and understand Italian because I was born and raised there. So these languages that we acquire, they can help us do some cognitive processes in ways that are still to be understood, but at least some of the time it helps because it helps us articulate some of the information that we're thinking about. So for example, well, in this case, we are communicating with language, so that's obvious. But even inside our brain, sometimes the structure that we acquire when we acquire language can help us process information. And maybe some of the time we even do it by literally, quote unquote, talking to ourselves in our mind. So, that's what that inner speech that I was talking about. But I don't think that's where it stops. So I do think there's a lot more to thinking than just either inner speech or inner imagery.
Yeah.
And if that's what you mean by saying, I don't think that there's the language of thought because we can think without relying on inner speech or imagery, I agree with that. And I think it's very important. And I think it's not sufficiently appreciated by the scientific community or the philosophy, the
Yeah.
philosophical community.
Yeah, I don't know much about this, Gualtiero, so I'm just making this up. It's wild speculation.
Well, you're good at
Um,
that.
so what I'm thinking is that uh, so language is sort of linear. So we have this large language models going on. I call them stochastic patterns. Others might call them artificial intelligence. Um, it's a linear process. So, you give me 7 words, and I'll tell you what the probability of the eighth word is going to be. That's truly a linear process. I'm not convinced that thoughts are linear. I have no evidence for it. I have no data on it. But I think thoughts are truly a parallel thing that we haven't quite understood. What do you think?
Yeah, I agree with that. But even large language models are very heavily parallel devices. So you can try to describe them as just predicting the next word, but I think
Mm,
that's an oversimplification.
mm,
They certainly do a lot of parallel processing, and they come up with very articulate,
yeah.
elaborate speeches. So yes, they are limited. Well, they're no longer limited to just language, actually.
Mm,
But they're very impressive in their use of language. But that doesn't mean that they are processing one word at a time, one after the other. They are
yeah.
processing a lot of things together as well. And I do think that our brains work like that in the
Yeah.
sense of there's a lot of parallel processing going on. Yes.
Yeah. So I have to sort of backtrack. So that's an oversimplification. So transformers at the latest innovation, attention, is sort of modifying in a parallel way what the next word is going to be. So it's not like, yeah, so I just assign a probability for the next word. There's more to it in the large language models. But I'm not sure thoughts are like that. It's this is my bias. I know nothing about it. It seems like thoughts are quite different from that. What do you think?
Well, I think that for us to have any kinds of rich thought life, mental life, there has to be a rich internal representational structure.
Mm,
Um, and meaning that there's a way for our brains/minds to model the domains that we want to think about, the various subject matters or targets of our
yeah,
thoughts, and then we can rely on that structure, the rich structure, to make inferences,
mm,
reason, think about what could happen in the different circumstances, what could happen if we do certain things, or what we should do. It's all also bound up with affect and emotion.
mm,
That's another, I think, important development in recent years and recent decades, that people are realizing that affect and thought are intertwined, and you can't really separate the two. They're not independent of each other.
mm,
But at any rate, yeah, so all of this can be used for um, thinking about, whatever we want to think
mm.
about. And a lot of it happens in parallel, absolutely. And I think a lot of similar things happen in large language models,
Yeah.
transformers, these kinds of technologies. There are recent studies showing that they do build, on their own, they build inner models of the targets that they need to be thinking about.
Mm.
So there are similarities there. I'm not saying that,
Hmm.
AI systems work like brains and vice versa, but there are some similarities.
Yeah, there's some similarity. So this is a sort of a hard problem for humans. We thought we were special. We thought we are the center of the universe, and astrophysics astronomers tell us, yeah, that's not quite true. We thought we were the most intelligent, and I think a lot of people still think we are the most intelligent, but it's very unclear to me we are that intelligent. So uh, nature keeps pushing us back into a
Mhm.
corner to say you guys are about the same as anybody else, and that has some educational value, right? So when Silicon Valley goes off and says, "Hey, we figured everything out. We got a sentient large language model." A recent Nobel laureate said, "This is the end of humanity. 5 years, you guys are all done. Sorry, I invented this." Um, um, it is a lot of stupidity, isn't it? I mean, I don't know. I mean, let me let you react to it. Yeah.
Yeah, so one thing we also have is overconfidence. We often think we understand things more than we do, or that we've figured out more than we have. I think it's premature to announce that our intelligence is superseded um, by AI. I think that um, we still there's still aspects of intelligence that we don't understand. And then besides that, there's the fact that um, to me, it looks at least very plausible that for us to fully exercise our cognitive faculties, we have to have some degree of consciousness, by which I mean
Mm,
phenomenal consciousness, experience, qualitative experience, objective experience.
yeah.
Um, and there's no reason to believe that current AI technology has any degree of phenomenal consciousness or
Mm,
qualitative experience, or that it will acquire it by just scaling it up or adding more computational power. Um, so consciousness is a whole other important aspect of our minds slash
mm,
brains. There's a kind of increasing number of people arguing that maybe consciousness depends on certain special properties of living systems, or at least certain kinds of physical systems.
mm,
Um, so yeah, conscious is another big area of debate where there are a lot of ideas, many of which implausible, and they tend to affect our perception of artificial intelligence in questionable
mm.
ways.
Yeah, so that's another um, big kettle of what's the right term? Worms? No.
Oh, can of worms? Yes.
Yeah, consciousness. So I want to finish up with your another paper, knowing that as knowing how, a neurocognitive practicalism, you say here. So you say here, to understand and explain how knowledge works in our brains, we have combined epistemology and cognitive neuroscience in the following way. The basic epistemic mechanism in our brain, which we share with most other organisms with neurocognitive systems, is a building and updating of internal simulations of our body and environment to guide our behavior. The simulation's accuracy comes in degrees. You say here in general, the processes that build and update such simulations are implicit, non linguistic, and unconscious. So that's the problem. Um, so, uh, so talk more about this. Yeah.
Yeah, so this is another place where the most influential tradition um, went along with that initial analogy that we picked up, that we started with, the software hardware distinction, and the
Yeah.
mind is all in the software. So if the mind's in the software, then our knowledge is also in the software. And the idea that we have a special language of thought for expressing our knowledge is part of that story. So, the influential version of this idea was that there is a kind of computer code that is the software of the mind, and it expresses our knowledge. And that includes even our knowledge of how to do things. So how do we do things? How do we drive a car, or ride a bicycle, or write with a pen, or type on a computer, or make food, or whatever? Well, we have like the right software, the right programs. They're written in the language of thought, and then we execute those like a digital computer.
Yeah.
But I actually think that it's the other way around, that our ability to express explicit thoughts in a language, like a natural language, really relies on a large body of know-how that we acquire. I mean, it could be a combination of innate traits and learning processes, developmental processes. But at any rate, we acquire these a little bit at a time.
By
From the
experience. By
Yeah,
experience.
well, by experience, and even before experience, by developmental mechanisms. Even in the womb, the
Mm,
babies in the womb, they already have sensory capacities. They start processing information in there.
mm,
Um, so you could call that experience to some degree. Um, and yeah, humans in particular are very inept when they're born. They can't do very much. I mean,
yeah.
typically they can figure out how to suck right away pretty quickly, because their survival depends on that. And then they start playing with their hands, and they start
They can
making,
smile and cry though. I mean, those
yes,
are
yes,
the
very
defensive
good.
mechanisms. Yes.
Yes, very good, very good. So yeah, they can do a few things, but not that much. Um, but
Okay.
I mean, other creatures are a little bit more competent when they're born. But regardless, okay, so there's some basic capacities that we have, and then we build on that, and we build other capacities. And even little humans, they eventually figure out how to articulate the right kinds of sounds, and then they start understanding some of the words that other people use, and they acquire those, and then they figure out the grammar and all that. Um,
Yeah.
but there's all these guys are know-how capacities. They are knowing how to do things. Some of
Mm,
some of these are practical, how to make certain sounds, how to move your hands in certain ways, how to walk. And then a lot of these capacities are internal.
mm,
How to process the information that's coming in certain ways, how to build internal models that predict how things are going to go under various circumstances,
mm.
how to, organize our muscles in forming actions of the certain source that we want to perform, and
Yeah.
compensate for that in processing the information that comes in. Because if you don't compensate for your own actions, you're going to get very confused about what's going
Mm,
on. It might seem like the world is shifting around, but instead it's you who are moving in the world, and you need to understand the effect of
mm.
that. So all of these capacities um, are needed, number one, for acquiring any kind of knowledge.
Mm.
And then number two, for acquiring knowledge that things are a certain way. So the
Yeah.
knowledge that things are a certain way, the like full propositional knowledge that we express when we talk to each other, are still the manifestation of a whole system of know-how, of knowing how to build internal models of the world and use them and predict things and so forth, and then
Mm,
filtering some of that information and expressing it in linguistic form. So really, knowing that is a
yeah.
manifestation of a whole bunch of knowing how.
So let me push on this, Gualtiero. So, from a philosophical perspective here, so building and updating these simulations, you say, to guide our behavior,
Yes.
is best described as a form of know-how plus its manifestation. One aspect of manifesting such know-how is carrying the information that things are thus and so an implicit form of knowing that. So I mean, this is a big area. So how do you differentiate between knowing that and knowing how?
Well, so what we argue, and this paper was written with Stephen Hetherington, who's a distinguished epistemologist, and he's
Yeah.
defended a view like this without really getting into the brain in a more like traditional analytic form. But then we joined forces and we tried to offer an account that takes into consideration a little bit about what we know about the brain. So what
Yeah.
we argue is that knowing how is the genus, is the broader category of knowledge, and knowing that is a species of that includes the manifestations of the know-how. So, so if once you know how to build the right kind of internal representations and use them and ground them in the facts. So for them to be knowledge, they have to be grounded in the facts. They have to be connected to, sensory motor representations and evidence that, are embedded, situated in the world. But once you have that, then there's aspects of that can constitute knowing that things are a certain way. So within all that, like parallel, as you say, parallel processing that involves all these representations, that you can, from the outside, you could identify like bits and pieces and say, that part represents a cat, that part represents a mat, that part represents the relationship of one being over the other, on top of the other. So the information that the cat is on the mat is in there implicitly. And if you have the ability to express it linguistically, well, now you can make it explicit, and the subject can utter the cat is on the mat. And so it expresses a piece of knowledge that things are a certain way, linguistically in a way that other people can understand.
So if you sort of rewind time 50,000 years ago in the African savannah, I would imagine knowing that was easy. I'm just making a statement. You can object to it. Knowing how is much more difficult. I have to go out and hunt and throw an arrow or something. So I don't know if I understand this correctly, Gualtiero. So in some sense, in a hierarchical sense, I don't understand this correctly. Knowing how comes afterward. That's not the case.
That's definitely not what we argue. So in order for you to know that things are a certain way, you have to have already a whole bunch of know-how. You have to know how to orient yourself, how to look in a certain way, how to process the information that's coming in, use it to update your internal model that you already know how to build, and how to rely on to guide your behavior. So what we defend is the view that know-how comes first, and then knowing that is either an aspect, an implicit aspect of that know-how, or a special case where we also acquire this ability to express it, in a linguistic form.
I mean, it has some implications for evolution and anthropology and other areas, right? So when we came down from the trees and we figured out how to walk, I guess we figured out how that knowing how part first, and then we figured out the rest, right? So is that how you're thinking?
Yeah, and so we normally attribute knowledge to lots of other species as well. It's not we
Yeah.
don't have a monopoly on knowledge as humans.
What?
Yep.
You totally surprised me. No.
Yeah, so without going too far, our other apes, know a lot of things, know how to do a lot of things. But even our pets, we talk about our dogs, our cats, they know things. They know they know that they're special person is coming home or is at the door or is
Yeah,
in the house or is taking them for a walk or is
they're
feeding
really
them.
good at it. They're actually better than humans
Yeah,
in many
sometimes they're
ways.
better
Yeah,
than humans, so they know
yeah,
all this stuff. So, but they also know how to do a lot of things, like they know how to, dogs know how to bark and they know how to chase and they know
mm.
how to play and how to eat and all that. So this account works for all these creatures. It's not just limited to humans. So we share a lot of these abilities with other creatures.
Excellent. So I know that I have to let you go. This has been great, Gualtiero. Thanks for spending time with me.
Thank you very much. It was fun.
Thank you.